Hello, Marlo. It's me again. Forgive the delay on the production of this video. My phone died and I couldn't shoot it. So here's the problem that you asked me about. 5 times the sine of x over cosine squared of x, yada yada. I've completed this problem a few times. I keep coming up with the same answer, which you'll see on your screen right now. I want to talk to you a little bit about how this happens. All right, so we're going to write each of these rational expressions just in terms of their factors, okay? So over here we have 5 times the sine of x over cosine of x times cosine of x. And we're going to multiply that by, well, let's see, in this numerator here, I see I can factor out a cosine of x. So I'm going to go ahead and do that. And that will leave cosine of x times sine of x minus 3. Okay? And that's going to be over, well, here we have a difference of squares. Sine squared of x, that's a perfect square, and so is 9. So I can factor that to be sine of x minus 3 times sine of x plus 3. Okay? And I think you'll agree with this factorization. If not, refer back to oh goodness, your notes earlier in the semester should have something about this. Okay. All right, so now I can actually write this as one single rational expression. So I'll write it as 5 times the sine of x times the cosine of x times the quantity sine of x minus 3. Right, because when we multiply rational expressions, we multiply every factor that's in the numerator and write it over the product of every factor in the denominator. Okay. Now, from here, you'll see I have one factor, which is the cosine of x in the numerator, and I have 2 factors, which are cosine of x in the denominator. I only get to cancel one of those factors. I also get to cancel this factor, which is the sine of x minus 3. And that leaves me with my result, which is 5 times the sine of x over the cosine of x times sine of x plus 3. And that is the final answer. Now, I think I know where you were going awry. When we go back to the original problem, you attempted to cancel both of the factors cosine of x on the bottom and cosine of x up here. You can't do that until you fully factor the numerator. Okay, because you will end up with an incorrect result every time. I'm going to show you why using plain old numbers, okay? No trigonometric ratios. Hopefully this will make it a little bit easier. So what I'm going to do is I'm going to write 3 plus 3 times 2, okay, over 3 times 3 times 7. Now, essentially what you were doing is you were saying, oh, I have 3 times 3 on the bottom, and I have 3 plus 3 times 2 on top. Let's cancel both 3's on the top and both 3's on the bottom. And if this were mathematically correct, I must say it's not, then that would leave us with 2/7 as a result. What you actually need to do, recall, whenever you have something written as a rational expression, that bar, the fraction bar, is actually a grouping symbol. And if you go back to the order of operations, that PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, we always have to take care of our parentheses, our grouping symbols first, which means that we need to take care of whatever's taking place in the numerator before we go ahead and try to divide, because that's a grouping symbol. In fact, if we were to write this out not using the large fraction bar, but just using the smaller division symbol, we would need to put this in parentheses in order to ensure that our expression means exactly the same thing. Actually, this is how you'd have to type it into your calculator. Okay? All right, well, disregard that for the time being. I'm going to take this expression again. What do we have? 3 plus 3 times 2 over 3 times 3 times 7. Now, if I honor the rule regarding grouping symbols, what I would need to do is I would need to, well, first take care of my multiplication, of course. We're playing order of operations here. So I have 3 plus 6 over, well, what is 3 times 3? Well, I guess that's 9 times 7. That's 63. And then I end up with 9 over 63. Well, actually, that's going to reduce because 9 goes in there one time and it goes in there to the denominator 7 times. So that's 1/7. Well, look, 1/7 clearly is not the same as 2/7. We ended up with two different results. The first way, I performed an improper cancelization, which I think is what happened when you attempted the trig reduction. And then the second time I followed order of operations. So the moral of the story is, please factor before you try to cancel anything. I hope this helps. If it doesn't, please email me again and I'll try another video. Thanks so much.